In this video, we're going to look at the relationship between inverses and derivatives. So just a quick review. Remember, the inverse function is just this little -1 notation after our function, and all it does is flip the x and y values of a function. So if f of a, if I put in a and get out b, by inverse, I put in b and get out a. How are the derivatives of inverses going to be related? Well, the first thing is, let's just look at for a nice point. There's a point here, 7, 3 on my original function. Doesn't know which one's the original, which one's not, but we'll use that point. All right. The derivative is the slope of the tangent line, which is going in about this direction. All right. And that looks like it's going about up 1 over 1, 2, 3, 4. So the derivative of my original function at 7 is about 1/4. The weird thing with derivatives and inverses is I know information about my original at 7, but because the x's and y value flip, my inverse function value is going to be at 3. Because 7, 3 flips to 3, 7. Right. I'm going to draw its tangent line. It's pretty close to that. And that one looks like it's going about up 1, 2, 3, 4 over 1, which is 4. So what do you think the relationship between a derivative of the original and the inverse is? The original function is 1/4. Its derivative is 4. They're just reciprocals to each other. I could also make the green function the original. Its derivative is 4. Its reciprocal is 1/4. So if I just do a reciprocal of a derivative, I'm going to have the derivative of the inverse. The only really confusing thing with inverses is the x values are going to change. So for one function, it's 7. For the other function, it's 3. So they're derivatives at different places, but there is a relationship of just being this reciprocal. And here's the notation. I think it's kind of confusing. What I just said, I think it's a little bit easier. But if I take the derivative of the inverse, that's the same as taking the derivative of the flipped value. So in the original question, this would be 3. This would be 3 into the inverse, which becomes 7. So the derivative of the inverse at 3 is 1 over the original's derivative at 7. All right, that flipping thing is what makes these problems kind of complicated. And this is exactly what I said here. You're kind of flipping the x and y values. All right, so a decreasing function satisfies g of 4 equals 6 and g prime of 4 equals -2. All right, which of the following statements of the inverse g must be true? So the first thing I have to know is that if g of 4 equals 6, g inverse of 6 equals 4. So the only thing we really know about g inverse is when the x value is 6. So right away I can get rid of this answer because it's not about 6. Right. And then the other thing I know is now that when I talk about 6, its derivative should go there. Its derivative is the reciprocal of this, which is 1 over -2. The answer is D. So even though 6 is not the x value from the original, it's the output. It becomes the thing we care about for the inverse. And then we take the reciprocal of the derivative at that point. All right, another AP question. For which of the following increasing functions does the derivative of the inverse of 20 equals 1/5? All right, so we want the inverse derivative to be 1/5. That means we want the original derivative to be 5. And then where is it going to take place? We don't really know. But let's just see. A, in my mind, automatically out. Why is A out? The derivative of A is always 1, so it's never going to be 5. All right, B has a chance. All right. First, we need to figure out where would the value be happening. All right, so this is the output of the original. So x cubed plus 5x plus 20 should be equal to 20. As the output, we need to figure out what the input was to get there. This is x cubed plus 5x equals 0. X times x squared plus 5 equals 0. All right, so at any of these x values, I plug that into my function and I get out 20. which means that's where you want to plug into the inverse. So these are the possible values. And now I need to figure out the derivative at these values. So the f prime of x is 3x squared plus 5. And when I put in 0, that goes away, and I get 5. And that's exactly what I wanted, so the answer is B. You would do the same thing for C. The actual problem's a little bit more complicated to solve. D, we haven't even learned about exponentials, so that's kind of one hint that this is not right yet, but you would know that for the AP test. But again, why is this the right answer? This is the output. This is the input for the inverse, which means that the output for the original. So that's how I got these x values. And then when I put those x values into my original derivative, I should get the reciprocal of the inverse derivative. So instead of getting 1/5, I get its reciprocal, which is 5. And so if I put in 0 into the derivative, I do get 5. All right, so this is kind of simple in the fact that it's one basic formula, but difficult in the fact that that kind of switching that happens with values with inverses is kind of hard to keep track of. But the inverse of a derivative, that doesn't make sense. The derivative of an inverse, I think these two should be switched. The derivative of an inverse is the reciprocal of the original derivative. And then just remember, you're flipping x and y values, so the numbers in the parentheses will look a little bit different.